Interrelationships in Earth and Space Systems, Section F, page 169. Tides are the periodic rise and falling of large bodies of water. Tides are caused by the gravitational interaction between the Earth, Moon, and Sun. Even though its mass is much smaller than that of our Sun, the Moon has more influence on Earth's tides because it is closer to Earth. The Moon pulls upwards on the water while the Earth pulls downward. The Moon has a slight advantage, and thus we have tides. Tides will be highest when the Moon is highest overhead. The gravitational attraction of the Moon causes the oceans to bulge out in the direction of the Moon. Another bulge occurs on the opposite side, since the Earth is also being pulled toward the Moon and away from the water on the far side. The result is high tides in both locations. The ocean level is lowest between the tidal bulges, producing low tides. Locations on Earth experience gradual changing tides as Earth rotates. It takes about 6.25 hours for the water level to change from high to low tide, and another 6.25 hours for the water to rise to high tide again. As you can see here on opposite sides, they have high tide, and then above and below we have low tide. Whenever the Moon, Earth, and Sun are aligned, as shown in the previous diagram, or with the Moon on the other side of Earth, the gravitational pull of the Sun adds to that of the Moon, causing maximum tides. Section G. Man's quest to understand the natural world is never satisfied. Throughout history, many different hypotheses about our solar system and the universe have been proposed. However, hypotheses often require advances in space observation and exploration to provide new data with which to evaluate them. As a result, scientists continue to search for answers and apply the methods of scientific inquiry to learn more about the universe. The idea that scientific ideas about the universe are durable yet subject to change as new data becomes available illustrates the nature of science. Four important astronomers who have helped mankind better understand the solar system are Aristotle, a Greek philosopher who lived from 384 BC to 322 BC, and he wrote about his observations of the planets. Aristotle believed in an Earth-centered or geocentric solar system. He believed that all celestial bodies in space moved in perfect circles around the Earth. His ideas lasted almost 2,000 years, until new observations no longer supported his ideas. Ptolemy, he was alive from 85 AD to 165 AD. He was a Greek astronomer and mathematician. Like Aristotle, Ptolemy believed that the Earth was the center of the solar system. Even though he started with a faulty hypothesis, he applied mathematics to what he observed about the movement of the stars to predict the movement of the planets. He proposed that the planets moved in small circles as they move around the larger circle surrounding the Earth. Copernicus, he was alive from 1473 to 1543. He was a Polish astronomer and mathematician, and he did not agree with Ptolemy's views that the stars orbited the Earth. He believed that the Earth rotated, which made the stars appear to move. Copernicus proposed that the Earth, orbited by its moon, was the third planet from the Sun. His sun-centered or heliocentric model contradicted the beliefs of those in power at the time. Therefore, some believe that Copernicus waited until he was near death to publish his ideas to avoid controversy and persecution. Galileo, he was alive from 1564 to 1642. He was an Italian physicist and astronomer. He was the first person to look at the moon through a telescope. He observed mountains and craters on the moon. Using his telescope, Galileo discovered 4 of the moons circling Jupiter, studied Saturn, observed the phases of Venus, and studied sunspots. Galileo's observations supported Copernicus's hypothesis that the Earth and other planets revolve around the Sun. Section H. With the development of new technology over the last half-century, man's knowledge of the solar system has increased substantially. Solar system exploration involves modern rockets, artificial satellites, orbital missions, missions to the moon, Mars robotic explorers, and unmanned exploration of the outer planets. Man has experimented with rockets for many centuries. The evolution of the rocket has made an indispensable tool in exploration of space. The timeline below highlights some of the major accomplishments in our solar system exploration over the past half-century. In 1957, the first satellite was launched, Sputnik, and this was done by the Russians. In 1961, the first manned spacecraft orbited Earth. In 1961, the first man in space was Russian. In 1962, first man orbited mission in the USA, and that was Glenn. In 1968, manned spacecraft orbits the moon. In 1969, the first man walks on the moon. It was Armstrong. In 1971, the first USSR space station. In 1971, the first soft landing on Mars. In 1973, U.S. space station was launched, Skylab. In 1976, Viking probe lands on Mars. In 1981, the space shuttle launched Columbia. In 1983, first probe travels beyond our solar system. In 1986, the Mir Space Lab launched. In 1989, the first probe to reach Neptune, Voyager 2. In 1990, the Hubble telescope was put into orbit. This telescope is still crucial to our exploration today. In 1995, Space Shuttle docks with Mir at Atlantis. In 1997, Mars Explored Pathfinder mission. In 1998, the International Space Station was created. In 2004, the Mars Explored by rover mission. In 2005, the first orbit of Saturn. And in 2005, the first soft landing on Titan, the largest moon of Saturn. This concludes the interrelationships in Earth and space systems.